Hello dear viewers, welcome back to another of my annual videos. So I've made several telescopes on this channel in the past and I've even put them on nerves and all. And I had a few random lenses lying about, so I thought why not go the other way around and build a microscope. And that is exactly what I did. It has a magnification of 55 times. This is a picture of a mosquito wing seen through it. This is an onion peel. Please ignore the bubbles. I made a really horrible slide, but you can see the cells, which is good. This image is of pixels on my phone, and it blew my mind that a pixel on my phone is actually smaller than an onion cell. The microscope has two lenses of focal length 1 centimeter and 5 centimeters. The lower one is adjustable using these rack and pinion and worm gears. There's also this light and its brightness can be adjusted using this piece here. It isn't a proper condenser and can leave image artifacts over the specimen because it focuses on a different plane than the specimen. So, how does a microscope work? This is an object. It is giving off light in all directions. This is another object, it is doing the same. This is the eye, it sees an object when light from the object falls on it. Some rays of light from the two objects fall on the eye and we can see them. This is angle A, it is the angle between the rays from object 1 and the rays of object 2 that fall on our eye. For us to see object 1 and object 2 clearly, angle A must be greater than a fixed value. This value for the human eye is 0.02 degrees. If the angle is any smaller than this limiting value, objects 1 and 2 will merge into each other and we will be able to see only one object instead of two, and that merged object will have the basically the merged colors of 1 and 2. This limit can be reached when the objects move closer to each other or when the objects stay at the same distance from each other but move further away from the eye, and when that limit is crossed of 0.02 degrees. When this limit is crossed, we can't see the objects as separate anymore. We want to see an onion cell. It is 40 microns thick. This is wall 1, this is wall 2. For us to not see a blurry mess, the rays from wall 1 and wall 2 must make an angle greater than 0.02 degrees. That means keeping the eye 11.4 centimeters away from the cell. The problem is we can't focus on anything that is closer than 25 centimeters. At 25 centimeters, the angle is 0.009 degrees, much smaller than the limit. And even if we manage to keep our eye at 11.4 centimeters from the onion peel and focus on it, the angle will be 0.02 degrees, which means that the walls will just be differentiable from each other, and that won't really help us very much. This is where the microscope steps in. This is the objective lens, this is the eyepiece. These are 2 points on the specimen separated by a distance d. This is the intermediate image plane and these are the rays. Now using the image equation for a lens and basic trigonometry, we can find the angle beta in terms of d. Now the angle when seeing it with the naked eye, gamma, is this, which gives us a magnification equal to 55 times when we divide beta by gamma, or when we see how much bigger beta is as compared to gamma. That means that if there are 2 points and you look at them through this microscope, they'll appear at an angle that is 55 times further apart than what you would have seen with the naked eye.